So in this video, we're going to talk about how to use a multiplier to find percent growth and percent loss, and how that's going to relate to exponential equations, setting them up to solve scenarios. So first off, we have to consider, how do we find percent growth? For example, what if I wanted to find 3% growth on 20,000? Okay, well, then first, obviously, I would want to know, what is 3% of 20,000? Because if I need 3% growth on it, then I'm considering I need to know what 3% of it is. So I need to find that. So let's do 20,000 times 0.03. So that's 3% as a decimal. We're multiplying it. That's going to give me 600. Okay, so 600. If I want a 3% growth on the 20,000, I'm going to have, this is a growth, right? So I'm going to have a larger number. What do I have to do? I'm going to have to add that 3% on. So I'm going to get that 20,000. And then I'm going to add on the 600. And that gives me 20,600. Well, there you go. Well, let's say I wanted to do that 10 times. Let's say I wanted to do, let's find 3%. It grew at 3% 10 times. Well, if I'm solving it this way, what I would have to do would be then to take this, find 3% of it, so times 0.03, and then add that. So multiply that, find 3%, add that back onto this. Then I'd have to take that number, multiply by 3%, find what that is, add that back onto this number. Then I have to take that number, and you can see we're getting into kind of a process here, right? So there is a better way to do this than to have to find 3% every time and then add it back on. 3% add on, 3% add on. That's going to get tedious, and we won't be able to just toss that into a calculator quite as easily as if we use another strategy here. So let's consider what is happening here in terms of percentages. We know that we're having 3% growth, right? 3% growth, that means we're adding on 3%. Okay, adding on 3%. So 3% of 20,000 is 600. Well, what percent of 20,000 is 20,000? 20,000 is all of 20,000, right? It's the whole thing. What percent is the whole thing? What percent did you get on your test if you got everything right? All of it. What is all of it? It's 100%. So if I have 100% here, and this is 100% of what we had, 20,000. Now I'm adding on 3%. That's the 600. Well, what's that going to give me? It gives me here it gives me 20,600. Of course, that's the value. But what does that give me percentage-wise? That is 100 plus 3%, which is 103%. Okay. What if, instead of finding 3% and adding it on, I just took it in one step and said, I'm going to find 103% of 20,000. That is the 100% we started with plus the 3% growth will give me 103%. So if I find 103% of 20,000, it should give me a 3% growth. Okay, well, how do I find 103% of a number? It's just the same way we find a percent of any other number. I have to turn this into a decimal. So first things first is 103% gets divided by 100, which turns that into 1.03. Slid the decimal over twice, 1, 2, 1.03. So let's look at that. What if we were to just find 103% of that? So multiply 20,000 times 1.03. What's going to happen there? 1, 2, 3. So multiply times 1.03, and that will give us 20,600, which we know is the 100% 20,000 plus the 3% 600. And there we go. It worked perfectly. And that's how you can find a percentage growth. You can always start with 100% and then add on the percentage, and then you can use that percentage to find what you're looking for here. In this case, it was 103%. You divide that by 100, and it would be the 1.03. So let's consider a different example. What if I wanted to do a 5% growth? If this was a 5% growth, then that would be the 100%. I add on the 5%. Okay, well, that's 105%. What's 105% as a decimal? It would be 1.05 would be our multiplier, which is what we're calling it in terms of because that's what we're multiplying by. So 1.05%, this would be a 5% growth on whatever you multiply it by, because it's finding 105%. 100% what you have, 5% extra. What about a 0.5%? Well, I would just do the same thing. 100% plus a 0.5% is 100.5%. Divide that by 100 to get your multiplier would be 1.005. And there you go. That is your multiplier to find a 0.5% growth. All we're doing, start with 100%, add on whatever your growth percentage is, and then you can turn this into a decimal and use it as your multiplier. What about percentage loss? Now it works so similarly. What if we wanted a 3% loss on 20,000? Well, then of course we'd have to find 3% of this. Well, we know 3% is 600, right? Now, if we're losing that, instead this time we would do 20,000 minus 600. That's going to give us 19,400. Right? Well, let's again think of this as percentages. We know that 20,000 is all that we have, which is the 100%. And then we know the 600 is the 3%. What's the difference here? The difference is this is a loss, and we're subtracting these numbers, right? 100% of it minus 3% of it should give me, in this case, 97%, right? If I lost 3%, then I have 97% left. So all you have to do then is find 97% of 20,000. So again, we can rewrite 20,000, and if we multiply by 97% as a decimal, 0.97, that should give us 19,400. Let's check it. Here, 20,000 times 0.97, 19,400. Look at that, 19,400. It's because I have 97% left if I lost 3%. So if I find 97% of this, then it should give me what was left after we lost 3%. So same thing down here. If I'm losing 5%, then you would subtract the 5%. You'd say that's 95%, and the multiplier would then be 0.95. If I'm losing a 0.5%, you'd subtract. So you'd start with 100%, subtract the 0.5%. That gives me 99.5% left, which means the multiplier is 0.995. There you go. You always start with 100%. If you're growing, you add it on. If you're losing it, you subtract it away. The most common thing people do is just find 3%, and they say, "Oh, it's a 3% loss," and it doesn't bother them that because it's a smaller number. Like over here, it should really bother you if it's growth and you just find straight up 3% of this, and it goes from 20,000 to 600. You'd be like, "Whoa, that's not a growth." But here, it really throws people off. They find 3% of that. It's a smaller number, and they say, "Oh, it's okay. It's a smaller number, so that must have been a 3% loss." But we have to remember that we're starting with 100%, taking away the 3%. That leaves us with 97%, and that's what you're finding. So let's look at a couple examples of how this would work when we're using it with exponentials. So the population of Denver is growing at a rate of 1.5% for the past 10 years. If the population 10 years ago was 600,000, how many people are there now? So we're always, the ones we're working with, the exponentials we're working with are always in this form: y equals a times b to the x, where it has a y-intercept or asymptote at y equals 0, right? So y equals a times b to the x. And we know this is a starting value and this is a growth factor. Now, this growth factor, when you see percentages like this, it's going to be the multipliers that we just talked about. Those multipliers that we just talked about, and we're going to have to find them. And then hopefully we've got some other value that we can use for the starting value. Well, in this case, population 10 years ago was 600,000. So that's a pretty clear value for our starting value. Now we just have to find, what is the multiplier? Well, it's a growing, right? It's growth rate at 1.5%. So we need 1.5%. So 100% plus 1.5 is 101.5%, which means our multiplier, when we divide that by 100, will be 1.015. Okay, we can write a nice little equation for that then. Y equals the 600,000 that we're starting with, and then multiply by 1.015. That's the 1.5% growth, and we need it to happen for some amount of years. Now I'll say that y will be total population, total pop, and let x equal the years that have passed. So we've got a starting 600,000 growing at 1.5% for some amount of years will give us the total population. Now it says how many people. Do we got to plug that into a calculator. Now it's going to be easier for me to plug that into a Desmos calculator. 600,000 times 1.015 to the 10th. 600,000 96 324. 696,324 people, call it. And that would be your answer. Now, very similarly down here, this is saying Detroit's population has been declining by 0.7% each year since 2015. If they had a population of 690 in 2015, what's their population now? So what we'd be looking at, of course, we've got another starting value here, 690,000 as a population, using these same let statements. And then we have to find this. We're starting at 100%, but we're losing 0.7%. What's that give me? It's 99.3%, which means that the multiplier is 0.993. So we just need to write an equation here. Y equals 690. That's my starting value. I'm losing 0.7%, so use my multiplier here, and for every year. All right, so it says that it's happened for the last 5 years. So we're going to do that 5 times. We're going to plug that into the calculator, 690.993. 5 years, that makes it 666,185. And there you go. That's how you can use exponential equations and our percent growth and loss multipliers to solve situations like this, where we're over time growing at certain percentages or losing certain percentages. This is going to apply to a lot of things in your life, particularly when you're dealing with finances. Of course, you'll want to have it in this form. We have some starting value, we have some growth or loss multiplier, and we're doing it a certain amount of times.